Underground mining requires a lot of equipment. The majority of that equipment is powered by diesel engines, so to ensure that the miners in the mine have an adequate supply of fresh air, there are ventilation shafts at intervals throughout the mines. Some of these shafts are intake or downcast shafts. Others are exhaust or upcast shafts. Winter sub-freezing temperatures often interfere with the airflow in the intake shafts because the cold surface air passing down through the moisture-laden rock tends to cause a buildup of ice. Subsequently, a few shafts are equipped with large heaters to warm the incoming air. Other shafts have the capability to periodically reverse the direction of airflow to keep the ice in check. Several years ago, one mine experienced a problem with the shaft. This particular shaft had a huge volume of water entering it through flaws in the bedrock. There was enough flow that the water never froze, kind of like when you leave a faucet running on very cold nights. This particular winter, the shaft began freezing up and restricting airflow enough that the 6-foot diameter, 350 horsepower fan that was pulling air down it began to surge. I used a camera specifically designed for viewing conditions in wells and ventilation shafts to investigate the problem and found that the shaft was nearly plugged by ice at a depth of approximately 400 feet. Sadly, I neglected to take a picture of the ice blockage. A few days later, when the weather warmed to above freezing, I sent the camera down again and found that a large slab of rock had detached from the side of the shaft and bridged across it well above the major water inflow, causing a flow restriction. In an effort to dislodge or break the slab, we dropped several pieces of junk drill steel down the shaft to no avail. We then located a very heavy cutting edge for a loader bucket. This was unused and quite expensive, but we figured it would survive unscathed and we could retrieve it from the bottom of the shaft. Although the cutting edge successfully hit the target as planned, it ended up laying on top of the slab without knocking it loose. In desperation, we went underground to a powder magazine and got 3 sticks of dynamite, a detonator, and a roll of shock cord. Using the camera, we were able to hang the dynamite from a long piece of rope and lower it into position on top of the slab. In anticipation of a huge spectacle when the blast went off, I recorded the scene, but it turned out to be quite a disappointment as far as noise goes. Aside from the less than impressive noise level, the blast performed as hoped and turned the slab to rubble. The cutting edge managed to land vertically and plunged deep into the pile of rocks that had accumulated at the bottom of the shaft over the years. No one, me included, felt it was safe to go out underneath the open shaft to try to retrieve the cutting edge, but I doubt it would have been budged out of the pile without mechanical assistance, and that area was only accessible on foot. And that's the story, and it proves the adage that every problem can be solved with explosives if applied correctly.